Okay, so chapter 8. Chapter 8 is a pretty big concept for us. It is all about what we call hypothesis testing. Okay, so chapter 8, that's what we're going to be exploring. In 8.1, we're going to do a lot of kind of the explanation behind it and a little bit in 8.2, but 8.2 is actually where you're going to be doing a lot of hypothesis testing in pieces and kind of putting it all together towards the end. And then 8.3 and 8.4 really kind of dive into a little bit more about hypothesis testing and some things that you'll see and do and stuff like that. So this is kind of going to be a gradual process when we go through hypothesis testing, but it's all chapter 8, only 8.1 through 8.4. Okay. So 8.1 is just going to kind of be the basics. There's a little bit of math, but not a lot. It's all about knowing what you're looking at and understanding what we're talking about. Okay. So let's dive into 8.1. So the explanation of hypothesis testing. Well, the first thing is, what the heck is hypothesis testing? So hypothesis testing, what it is, it's a procedure that enables us to choose between two claims when we have variability in the outcomes. Okay. So this allows us to talk about two different ideas, two different hypotheses, and determine whether we want to accept or reject. So that's kind of the big idea that's going on in here. And so hypothesis testing has 4 steps. First one is state the hypotheses. The second one is preparation. The third one is you're going to collect data and compare to expectations. And the fourth one is to interpret. Okay. All right. So those are the 4 steps. I don't believe I have anything underneath that. And throughout 8.1, we're going to talk about each one of these. This is also a little bit in the 8.2. 8.1 is kind of written up like a recipe where they really do talk about all 4 of these steps, but they do it kind of like a recipe style. So I'm kind of taking it out of that format a little bit, but you're getting the same information in 8.1. And I'm also throwing you a little bit of 8.2 information because that's actually the name of the steps in 8.2. So it's a little different than how this is presented in 8.1. So let's talk about state the hypotheses, because what you're doing in this step is you're going to it's basically a claim is weighted against the skeptical claim. This is the most important step because we got to know what we are testing. Okay, so you're going to have one claim and it's going to be weighted and compared against the skeptical claim. All right, and these 2 claims, they have names. We call the first claim the null hypothesis. Okay, the null hypothesis, and we call it a capital H with like an O down here. It's like a 0. We call this H naught. Okay, H naught. The null hypothesis, it is a neutral, status quo, conservative statement about the population parameter. Okay, super important. It is about a population parameter, not a statistical parameter or statistics. It's about the population. Okay, so it is a neutral, status quo, conservative statement about the population. We call it H naught. And then the skeptical claim is what we call the alternative hypothesis. Sometimes we also call it the research hypothesis. Okay? It is a statement about the value of a parameter we intend to demonstrate is true. Okay? It is a statement about the value of a parameter we intend to demonstrate is true. It is capital H with a lowercase a. We call it ha. So our null hypothesis, H naught. Our alternative hypothesis, ha. Okay? Again, this is about a parameter, which means it's about the population. So just a couple little notes down here. When we are dealing with the hypotheses, They are always about the population parameter, both of them. Okay? The only difference is in how we write them up. Okay? So let me show you how these are written up. But again, super important, it's always about that population. Okay? P. All right. So how it is written up? Well, you have two types of hypothesis testing. You have what we call a two-sided or two-tailed hypothesis test, or you have a one-sided or one-tail hypothesis test. Okay? Notice H naught, or the null, is always P equals whatever that value is. H naught always has the equal sign. Will never ever change. It's the ha, or the alternative hypothesis, where you change it up. And again, notice it's still P and P0, or sometimes we call this P naught. Okay? All you're doing is changing the equal either to a not equal, which is a two-sided, or you're going to be less than, or you're going to be greater than. It's going to be one of those three symbols. Okay? That's how we write up our hypothesis. And we're going to get a lot of practice with this because this is the most important step. Okay? So H naught always has equals. Okay? H, the alternative hypothesis, or ha, is either not equals, less than, or greater than. It's one of those three symbols. Okay? So this is always equals. And then down here, it's one of these three symbols. If you are less than or greater than, you're a one-sided tail. If you are not equals, you're a two-sided tail. Again, we're going to talk about more of those tails in 8.2. Okay? All right. Couple other pieces of information. The null hypothesis is always true throughout the entire procedure. From the very beginning, steps 1 all the way through step 3, the null hypothesis is always true. It is in step 4, the interpret, where things could switch up on us. Okay? So the null hypothesis is always true throughout the entire procedure. It's in the last step that things could change on us. Okay? And that's what I'm saying right here. The null hypothesis is only rejected when the last step observation is extremely unusual under the assumption. And we're going to talk more about that coming up. Okay? But it is only until the last step where we might reject the null hypothesis. Okay? Notice I didn't say it was false. I just said we reject it. There's a difference between saying it is not true or rejecting. Okay? So we either accept the null hypothesis or we reject it. Those are the only two options. And there is a difference, trust me. Again, we're going to talk more about that as we move on. Just kind of giving you the brief overview here. That's kind of what 8.1 is. So let's talk about these. So right here, kind of giving you a question. It says, choose one of the answers in each case. So in the blanks here, it's either sample or population. So it says, in statistical inferences, measurements are made on a blank and generalizations are made to a blank. Okay? Fill in those blanks for me. Who do we take measurements on and who do we make generalizations about? And go. Okay. So hopefully in this first blank, you said that measurements are made on a sample. Okay. Generalizations are made about a population. Okay. We rarely can perform measurements on populations because it's all unknown. Remember, populations encompass everybody. So it's very, very hard to find mean, medians, and modes on a population. But measurements we can definitely do on a sample. They're more manageable. We can find mean, median, and modes, and standard deviations and all that stuff on a sample. Okay? Hopefully that makes more sense than this. All right. So now let's jump into actual talking about null hypothesis and alternative hypothesis. So in here it says, suppose an experiment is done with criminals released from prison in a certain state where the recidivism rate is 40%. That is, 40% of the criminals return to prison within 3 years, basically after being released. 100 random prisoners are made to attempt a boot camp for 2 weeks before their release. And it is hoped that the boot camp will have a good effect. This is important right there. Good effect. Okay? The null hypothesis is that those attending boot camp have a recidivism rate of 40%. So they stated the null hypothesis in words, and right here they're telling you the null hypothesis in symbols. P equals 0.40. That's 40%. Okay? So it says report the alternative hypothesis in words and in symbols. Okay? So let's talk about this. We know that this is P. We know that this guy has to be 0.04. They have to be those numbers. The only thing that we're questioning in here, is it a not equals? Is it a greater than? Is it a less than? Well, this is where you got to make sure that you are reading carefully. Okay? So up here, that's why I highlighted this word good effect. What does it mean to have a good effect? Well, a good effect on prisoners would mean that they're not coming back to jail. They're not coming back to prison. Okay? So that means we're hoping that this percentage, or 0.4, is less than. We're hoping that it's not that high of a percentage of those coming back. That means our boot camp is having that good effect. I hope that makes sense to you. Most of the time, it's going to be fairly obvious as to which one they're going to work. Most of the time, they're going to say, we hope that this decreases or lowers something. That would be a less than effect. Or we hope that it increases or raises this percentage. That would be a greater than. Usually when you don't see anything about like increasing or decreasing within the problem, that means it's your not equals. Okay? So it's easy to get the symbols. Now let's talk about what does this mean in words. Okay? So it's easy to get the symbols. Now let's talk about in words. And of course, this is going to be in multiple choice for you. But basically, in words, what this is saying is that the proportion, because this is all about a proportion, of criminals who attend boot camp who return to prison is less than 0.40. That's what this is meaning in words. Because this P was about the proportion of criminals who return to prison, okay? Who have attended boot camp. So we're hoping it is less than. So it's just asking you to put this into words, what's going on. So this P represents the proportion of criminals who attend boot camp who return to prison. We're hoping it's less than 0.04. Okay? So there we go. Try this one on your own. All right. So in this one, hopefully as you're reading, you're going to see that, oh, I see a word in here that's very specific, like the good effect. And then right here, can lower the rate. That's important to us. Can lower the rate. So again, as they've given us here, they've given us the null, which P is equal to 0.04. Hopefully your symbols of ha, or the alternative, is P, 0.04, and can lower means that we want the less than symbol. So hopefully that's your ha. And then as your explanation, the proportion, let's make all this red, just like last time. Keep it all red still. The proportion of infections is less than 0.04. Because this P was about infections. Okay? So we're hoping that the infection rate goes down. Okay? Always important to make sure that you understand what the proportion is about. And in this case, it's infections. All right? Try it again. This time it's just a multiple choice. And go. All right. So, in here, when you're looking at these, obviously anybody that has a P hat, you have to throw out. Okay? P hat is gone. So all these that have P hats, you ignore. So really you got a 50-50 shot on this. All right, now how do I know which one is which? All right. The key in this one, again, you're looking at these 18 and 30. If you take 18 divided by 30, you get, and I don't know it off the top of my head, 18 divided by 30, you get 0.6. So some of you are probably going to go over here and circle this. But that's an experiment. That's a statistic. Remember, this is all about the population. What do I know about the population? It's right here. So what is your population proportion? 50%. This is a trial. This is an experiment. Okay? You've got a 50-50 shot. Okay? Your P is about if they can guess the right type of water. Is it bottled or is it tap? Okay? Then down here, remember it's got to relate with the same number, so obviously it has to be this one. And even if it was the 0.6 up here, down here there's no 0.6, which that means something's weird if there's no 0.6 down here to go off of. Okay? So obviously you know right away that 0.6 doesn't make any sense as well too. Okay? Because the null hypothesis and the alternative hypothesis have to deal with the same number. Have to. Okay? All right. Do it again. I told you this is the important step. I'm going to give you lots of practice doing this. So it says the proportion of people who live after suffering a stroke is 0.85. Okay? So obviously you can see the 0.85 down here. Suppose there's a new treatment that is used to increase the survival rate. All right, so there's important. We want to increase the survival rate. Use the parameter P to represent the population proportion of people who survived after the stroke. For a null or for a hypothesis test of the treatment's effectiveness, researchers use the null hypothesis. So right there is the null. So here's H not. Okay, they want to know which one is the correct alternative. Well, since we want to increase the rate, the only one that is correct is number 2. P greater than 0.85, because we want to increase the survival rate for people. We want this number to be higher, which means that P is about surviving. So we want more survivors. Okay. And I believe this is the last one on the hypothesis again. So this one is having you pick the correct null hypothesis. It says you roll a 6-sided die 30 times and land on an ace, which is the number 1, 6 times. You want to test the hypothesis that the die does not come up with an ace 1/6 of the time. Okay? Pick the correct null hypothesis. So right here, they told you the alternative. The die does not come up with an ace 1/6 of the time. So that means they're telling you H naught is P does not equal 1/6. See right there, you can see how it doesn't say it's either increasing or decreasing. It just says it is not this number. And usually that's how you'll recognize and also a does not equal. When it says it does not happen, that means does not equal. That's a two-sided tail. Okay? So which one of these match this? And again, anything with a p hat goes away. So we know that that's gone, that's gone. So it's either 1/5 or 1/6. And the answer has to be the 1/6 because it has to match that number. Okay? Again, if you took the 6 over the 30, you are figuring out the experiment proportion. You're figuring out p hat. We don't want p hat. We just want p. Okay? All right. So you got to make sure that you know your hypotheses because that's going to tell us a lot of what's going to happen when we deal with this. Most important. Okay. Now in the preparation, here's what's going to happen in the preparation. In the preparation, it's all about how do we use the data and do we have enough data? Okay. So everything that's happening here is you're going to state the significance level. And again, this is all about how we're going to use that data. You're going to choose a test statistic appropriate for the hypotheses. And again, this is all about how we're going to use that data. And then you will check conditions required for future computations. So this is where we're going to figure out, do we have enough data? There are 4 requirements to check, a lot like what you experienced in the central limits theorem. Okay. So there's going to be some conditions to check, and then there are 4 of them. And then you're going to state any assumptions that must be made. Okay. Again, I'm just doing an overview of this. The thing I want to talk about with you right now is all about the significance level, and then I'm going to talk to you about the test statistic here in just a second. Okay, the checking conditions and things like that, and these last 2, that's going to come in 8.2. Okay, and this one we want to talk about the significance level and the test statistic that we're going to be using. Okay, significance level, what it is the probability of making the mistake of rejecting the null hypothesis when the null hypothesis is really true. Okay, we call it alpha as the notation for it. And there are 3 that we generally use. Most of the time we're going to use a 0.05. Okay, so we're going to use a 0.05 significance level. Okay, but other times we sometimes will use the 0.01 or the 0.10. Okay, so again, this is a probability that we're going to make the mistake of rejecting the null hypothesis when it actually really is true. Okay, so right here, basically it's a fill in the blank. It says we are testing someone who claims to have ESP by having the person predict whether a coin will come up heads or tails. The null hypothesis is that the person is guessing and does not have ESP. The population proportion of success is 0.5. So again, if you're kind of thinking about this, H sub 0 is P equal to 0.5. Okay? And again, or 0.50 if you want. P is the person is guessing and does not have ESP. Okay? And the population proportion of success is 0.5. Okay? So it says we test the claim with a hypothesis test using a significance level of 0.5. So this is important for us. There's our significance level. So we want to fill in what's going on here. So it says the probability of, and this is all about the significance level, the probability of concluding that the person has ESP when in fact, okay, so remember this is about the significance level, so that means we are rejecting the null, but it's really true, okay? So we are concluding that the person has ESP when in fact he or she really, what's the null? Does not. So in this blank goes does not have ESP is what? What's the probability? Well, again, that's your significant level there. So in other words, we're saying we have a 5% probability of concluding that the person has ESP when really they don't. That's the significance level. That's what it's telling us. We have a 5% probability that we're going to conclude this person has ESP when in fact they really don't. Okay? You try it. Pause the video and give it a shot. Okay. So hopefully when you're looking at this, let's read some things. It says a teacher is given an exam with 20 multiple choice questions, each with 4 possible answers. The teacher's null hypothesis, so right here we're getting the null, so H naught, is that the student is guessing. All right, the student is guessing, okay? And if they're guessing, that population proportion is 0.25. Okay? So suppose we do a test with a significance level of 0.1. They want you to write a sentence describing the significance level in context. So I'm going to use kind of the same format that happened over here. The probability of concluding that, okay, so let's type this out. I'm going to actually just going to grab my words up here. The probability that, I spelled that wrong, let's just grab it real quick, that the person is not guessing when in fact they really are guessing is, at significant level, 0.01. Okay? Because our P is about the person guessing. So significance level is about the probability that we say they are not guessing when in fact they really are. We reject this, but it really is true. We're dealing with a significance level of 1%. Okay? And there you go. Looks like a mint green. Let's adjust that to the actual green it should be, which is that one. There we go. All right? That's a significance level. They're just going to ask you some questions like that. Okay? Like I said, this section is like a giant overview. All right, so we're going to compute and compare. This is the third step. So this is where I'm going to teach you some math, and it's all going to be about what we call the test statistic. So we're going to compute the observed value of the test statistic. Okay, we're going to compare that with the null hypothesis. And then we're going to find what we call the p-value. Okay? That's what's going to happen in the compute and compare. All right? We're going to find all this information. So let's talk about this test statistic. Okay? The test statistic compares the real world with the null hypothesis. So in all this, that's what a test statistic is all about. It's a way for us to compare the real world with the null hypothesis. And one type of test statistic is what we call a one proportion z test statistic. A one proportion z test statistic. Okay? So let's talk about how we deal with this one. So we basically take our observations, we take that observed value, we find that p hat, give it a second, and we subtract it from our population parameter and divide it by the standard error. We get a z-score. Okay? Where standard error, just like what we've seen before, we take our population parameter times 1 minus the population parameter all over n and square root it. Again, p is the value of p, that is the null hypothesis, it's our population parameter. P hat is our observed value. That's like where, let's see here, if we're going back to those hypothesis right here, taking 6 divided by 30, that's our p hat. Taking, they don't tell us any information in there, right here, taking 18 divided by 30 and getting that 0.6, that's our p hat. Okay? So that's what we're talking about back in here. Give it a second to think about its job. So that's this guy. That's the observed value. Okay? All right. It's going to, this serves the same purpose as it did in chapter 3. Remember, it was all about how far away from the expected are we? Okay? So a positive z means that we are greater than expected. So we are above. A negative z means that we are less than expected. We are below. A 0 means that they are the same. So if you have 0, that means don't reject the null hypothesis. For sure. Because we want to be as close to 0 as possible. The further away we are from 0, bad news bears. Okay? We want to be as close to 0 as possible. All right. So here, go ahead, pause the video, and give me the information that you know about this. Okay, so this is the technology giving us the one proportion z test statistic. Okay. I will teach you how to deal with the technology in the next section. Right now, I just want you to do this by hand. So in 8.2, I'm going to show you technology. Obviously, you can see what I mean by a two-tailed. Okay. So hopefully by looking at this information, that gave you a lot of information for how this is going to work. Okay. For your null and your alternative hypothesis. So let's get those two pieces of information real quick. So the null, P, it says the dropout rate for all college students with loans is 30%. So the null is, I don't want to put an equal sign there, 0.30. That means the alternative, they say, because this is two-tailed, that gives you the one and only one idea that this thing has to be not equal. Because not equal has two tails to this. So there is part A. Part B says report the test statistic Z. Well, that's easy. You just look up there, and it's going to tell you what the test statistic Z is. And again, just make sure that you read the fine print because it will tell you if you need to round or not. And these directions that I'm looking at, they say 4 decimal places. So this would be 0.7715. And because this is positive, that means we are above okay, our expectation. We are above our expectation. All right. Now let's talk about how we do this by hand, because pretty soon, and there's only like 2 of these in here where you actually have to figure out the Z statistic by hand. Okay. That's why I'm going to show you the technology in the next one. All right. Because it just makes more sense in 8.2. So if we actually wanted to find this by hand, then we're going to take our P hat. So that's what we got to figure out first. And then right here is the information for your P hat. So you're going to take 65 divided by 200. So 65 divided by 200 is 0.325. Okay, and that makes sense that we are, the z-score is positive and that we said it's above because this percentage is above that percentage. It makes sense. Okay, so if we want the z-score, we're going to take 0.325 minus 0.30 because that's p naught. That's our p. And we're going to divide it by the standard error. Now to get the standard error, we need to take the square root of 0.30 times 1 minus 0.30. Divide that by n, which is 200. So if we go to our calculator, second x squared for the square root, alpha y equals for the fraction, 0.30, parenthesis 1 minus 0.30, close the parenthesis, scroll down to the bottom, hit 200, hit enter, and we get this long decimal, 0.0. So 0, 3, 2, 4, 0, 3, 7, 0, 3, 5. So that's what we're going to take all this information over here, divided by 3, 2, 4, 0, 3, 7, 0, 3, 5. So I go to my calculator, alpha y equals, put in my fraction, 0.325 on top, minus 0.30. And on the bottom, I'm going to go up and grab that number. Oops. A little bit harder to do. I'm going to have to type it in. So accidentally deleted my top piece out, putting it right back in. So on the bottom, scroll down, put 0.032. 4037035. Hit enter, and here's what the calculator gave us, which verifies this information. So not too bad to figure by hand. But again, I'm going to show you the calculator in 8.2, so we won't ever do this by hand again. That's just silly. So 4, 9, and 6. Which again, there it is, 0.7715. 0.7715. Over here, you actually see the p-value, okay, and what it is, which we'll talk about later, okay? All right. So there you go. You found the z-score. And again, that's kind of like what some of our technology looks like. This is the TI-84. Again, in 8.2, I'll show you StatCrunch in the TI-84 and how to do it. So right here, this again is going back to that boot camp example. It's giving you all the information you need so you don't actually have to go back to it. But they want you to find p hat, p naught, and compute the test statistic and explain it in context. Okay? So go ahead and give this one a shot. Okay. So to get p hat, all you have to do is take the 44 and divide it by 100, which is equal to 0.44. P naught, you already know, is 0.4. Okay. And again, back here, remember when we talked about this, we talked about the hypothesis, which was P equal to 0.04. And then the null hypothesis to this, which is what we had to find back in that exercise, was P less than 0.40. Okay. So again, compute this information. So we're going to find that Z statistic. So we're going to take 0.44 minus 0.40. We're going to divide that by the standard error. So standard error equals, almost forgot what I was doing. Square root of 0.40 minus parenthesis, sorry, not minus, parenthesis, 1 minus 0.40 all over your n, which is 100. So you just go to your calculator and you type in your information. So hit second x squared, then alpha y equals to put in the fraction, 0.40 parenthesis 1 minus 0.40, close the parenthesis, all over 100. And the calculator says that this is 0.04898974949. So that's what this number is going to get divided by, 0.04898974949. So when we go through and divide this, and again, they're going to want this to, it says 2 decimal places. No worries. So we'll hit alpha y equals, then we'll take 0.44 minus 0.40 all over, type out my number, 0.0489897949. And here is our z-score, 0.816496582. So if we rounded to 2 decimal places, we would get 0.82. So what does this mean? Okay. Using their phrasing. And again, you already have this phrase out there. You just got to type in the blanks. So this is not a phrasing that you actually have to come up with. Okay. So the value of the test statistic tells that the observed proportion, E hat in other words, of prisoners was, put in that number, 0.82. So that's the first blank you'll be filling in. And what is this number about? Okay, so this is a z-score, which represents standard error. Remember, z-scores are the standard deviation you are away from the mean. Okay, so that's the next blank that you're going to fill in. Standard error. And again, this is a drop-down menu, so they'll have the choices of confidence level, which that's not what this is, successes, standard errors, or proportion. Remember, z-score is all about standard errors. Okay, it is the standard deviation of the score. That's what a z-score is. It's taking the units away. Okay, so you got 2 blanks. You'll put the number in the first one and then tell me that it's standard error, because it's always standard error. Okay, and then the final blank that you got now is, it's a drop down. You'll either say above or below. Well, it's positive, so that means above. If that was a negative z-score, you would have selected below. The null hypothesis proportion of prisoners. There you go. Again, all this wording that I put out here, that's what they have. You'll be filling in the blanks. Okay? So you got 3 blanks. Again, the first one is the number. This is a drop-down menu. The z-score is all about standard errors. Okay? And then is it above or below? If it's positive, it's above. If it's negative, it's below. Okay? Just like what we talked about over here. Oh, nope, it was on that page. Positive z-score means we're greater than expected, above what we expected. Negative z-score means we are less than what we expected. Okay? So last but not least, let's talk about this p-value. Again, the calculator will help you find the p-value. I don't think we find it by hand. I can't remember. I have to look at that back up in 8.2 because that's where we'll really dive into the p-value. But in here in 8.1, we just want to talk about it. So the p-value, it is a number that measures our surprise, okay, by reporting the probability. So it's a probability that if the null hypothesis is true, a test statistic will have a value as extreme as or more extreme than the value we actually observed. We're going to talk about this as extreme as or more extreme than the value we actually observed as we dive in more. Okay, the big thing is more into this in 8.2, 8.3, and 8.4. The big thing is you need to understand that it's a probability. Okay, and what you need to understand about this probability is that a p-value close to 0 means that we have a surprise, that we should probably be rejecting the null hypothesis. A p-value that is close to 1 means no surprise. Okay? So the bigger the p-value, the less of the surprise. The smaller the p-value, the more the surprise. The more that we should probably reject. Okay? That's important to know. Because they're only going to ask you one in question and it comes after the interpreting. So once you know the p-value, this is where the interpreting comes involved. Okay? And in the interpreting, there's only really 2 things. Do we reject or accept the null hypothesis? And what does this mean in the context of the data? Okay? So in the interpret, do we accept or reject? And what does this mean in the context? Again, we're going to dive more into this as we hit 8.2 and 8.3 and 8.4. All right? We're going to talk a lot more about this. This is just giving you an overview of everything. All right? So again, there's only one example. This is the last example I have here, and then I'll tell you what problems to look at. So it says, suppose you are testing someone to see if he or she can tell Coke from Pepsi. Okay? And you are using 20 trials, half with Coke, half with Pepsi. So the null hypothesis is that the person is guessing. Okay? So that null hypothesis then, if we're thinking about it, again, if you're guessing, you got half Coke, half Pepsi. So, and you can obviously see the P right there. So that means that H of Z or H naught is P equal to 0.5. They are testing and hoping that that a person guessing that it's better than 50%. That a person guessing will be able to tell the difference more than 50% of the time. Okay? So they've ran an experiment. They said the person gets 13 right out of 20. The p-value they figured for you is right here. So it says, explain the meaning of this. So if you look at this p-value, remember this is a probability. Okay? So this value right here is very, very low. It's like 9%. So that means we probably should be rejecting this guy in the end. But again, more on that later. They want to know about the p-value. What is this stating? So in your assignment, this is like a multiple choice question, okay? And what they would tell you is this. Here's what this p-value really means, okay? Let's grab green. So this is the probability. Remember, that's what this is about. Oh, I keep forgetting that I. Probability that a person will get 13 or more right. Okay, see how it's all about that null hypothesis, and we're dragging in what we know. If the person is guessing, because P is all about guessing. Is, well, what is this guy as a percentage? 9%. That's what that p-value means. Okay? And again, we're going to talk more about p-value as it comes later on. But that's what this is trying to get at. That the probability of a person will get 13 or more right or correct if the person is guessing is 9%. Okay? Hopefully that makes sense for you. All right? Okay. So again, we're going to talk more about that probability as it comes. There's only one of these questions. It's a lot like this in your assignment. I'll even tell you it's question number 20. Okay? So look for a sentence that's generally something like this. All right? But again, in 8.2, we're going to talk more about, the real meaning behind what it says, that a test statistic will have the value as extreme as or more extreme than the value we actually observed. Okay? So there's a 9% chance that if we repeat this, we will get 13 or more right. Okay? There's another way of thinking about that p-value. All right. So your assignment for section 8.1, in the assignment chapter 8, only deals with questions 1 through 28. Okay? And that is section 8.1. Have fun.